All right, you guys, this is a review for your exam for tomorrow. I'm going to do a brief overview of chapters 5, 6, and 7, just a couple examples from each, and then it's going to be up to you to email me if you have any questions on any of the material, okay? So in chapter 5 for nomenclature, so naming, so for chapter 5 naming, there were 3 types that we talked about. There's type 1, which is a metal from the main group, plus a non-metal, right? Metal is listed first. Followed by the non-metal. And it's the root from the non-metal, and the ending becomes IDE. Remember that? So if we have, let's see, what would be a good one? We've got, let's do an unusual. Let's do strontium and fluorine. You thought I was going to do sodium chloride, didn't you? So we have strontium and fluorine. Strontium as an ion is a 2+ charge. Fluorine, which is F, not Fl, is a 1- charge, right? We're going to crisscross the charges, and it becomes SrF2. Follow our naming convention up here. Strontium is the metal, it gets listed first. Fluoride is the second one, Fluoride. So it's fluorine, the root of fluorine, plus the ending gets changed from INE to IDE. Okay, so you guys should be pretty familiar with those. So that's type 1. Type 2, it's a little trickier, right? So what's in a type 2? It's a transition metal, or other metal, not main group, right? Plus a non-metal, okay? The naming is similar to the type 1, however, with type 2, there's a Roman numeral that has to be written next to the metal in the name. So let's look at Fe2O3. If we were to take this and break it apart and try to name it, we're going to uncrisscross the iron and the oxygen charges. That's where we end up with a iron 3+. The iron comes, the 3 is from uncrisscrossing it next to the oxygen. That means the 2 would have belonged to the oxygen. And we have a 2-, right? The name of this is iron, Roman numeral 3, oxide. Okay? Iron 3 oxide. The 3 charge is indicating that it needs the Roman numeral next to it. Okay? Let's do one more of these because I know these get to be a little more confusing. Just one more. Let's do copper 2 hydroxide. Let's split it apart and see if we can write the formula. We've got copper that the words are telling us have a 2+ charge. OH, which is hydroxide, that's one of your polyatomics, has a -1. If we were to write this out, I'm going to combine and crisscross the charges. We have Cu gets the invisible 1, OH in parentheses, right? The hydroxide stays together. The hydroxide gets the 2 that belong to the copper, right? So those are type 1 and type 2, right? I'm going to pause this for just a second. Okay, type 3. That is a nonmetal plus a nonmetal. This is the one that uses prefixes to tell us how many of each of the nonmetals are in the formula. So if we have Ni3, we know N is nitrogen, we know I is iodine. We also know that they're both nonmetals. So if we were to write out the name of this, it's going to be nitrogen 3 iodines is triiodide. So that's nitrogen triiodide. Okay. You guys know a lot of these, you know, carbon monoxide, right? CO2, carbon dioxide, right? And so on. So it's two nonmetals together using prefixes to describe how many of each are in the compound. Pausing it again. Okay. You guys have a sheet of polyatomic ions. Things are a little bit different now, so you guys do have the sheet. I hope you've memorized them, but there's a lot of them that you should be using over and over again. That'll just be second nature too, like hydroxide and nitrates and things like that. There's also something called oxyanions that we sort of talked about. So if we have oxyanions, these are, there's certain rules for when you're naming them. So oxy means that there's oxygen involved in it, right? So we have species with a fewer number of oxygen atoms. The suffix is ITE, okay? The species with the greater number of oxygen atoms, the suffix is 8, okay? So we have ITE and ATE. There were a few other ones that we talked about, but let's just look at this. I'm going to give you one example, and you guys can go back through the notes from the class for the other ones. So if we have SO4 2-, and we have SO3 2-, let's look at these two. You know, there's a sulfur and an oxygen. You guys should be recognizing sulfate, SO4 2-. You use that a lot. But let's look at our rules and how this applies. Okay, so how many oxygens do we have here? We have 4. How many oxygens do we have here? We have 3. So this one is sulfate. Okay, that means the one with the fewer oxygens is sulfite. Right? We talked about naming acids, and let's get another sheet of paper. So when you're naming acids, let's look at, oh no, where'd it go? Sorry about that, my screen went away. Okay, so when you're naming acids, we're going to take the root name of the central atom of the anion. Okay. We're going to, let's use this one as an example, HNO3. Okay. We're going to be adding ic if the polyatomic part of it ends in 8. Okay, what did I just say? We're going to add ic if the polyatomic ends in 8, right? What's that polyatomic? That's nitrate, right? So this is going to be nitric acid. Okay. If these are for ones that have oxygen. Okay, there's oxygen in the name. Okay. If no oxygen, let's look at that one. You guys should be knowing by now that that one's hydrochloric acid, right? If there's no oxygen, the name will begin with hydro. And end with ic acid. So look at the central is chlorine, so it's going to be chlor. So we have hydro, chlor, there's the root, ic acid. Okay. Pausing, need new paper, hang on. Okay, so that was pretty much a summary of chapter 5. Chapter 6, we looked at chemical reactions, different types of chemical reactions, and how we would be writing out the reactions with the reactants on one side of the reaction arrow and the products on the other side. Okay. This is where we learned to write states of matter, and this is also where we learned how to balance. So I'm going to be taking and walking you through just an example here. So if we were to combine magnesium sulfate with sodium phosphate. Okay. Let's look at, I'm going to give these to you and tell you they're both aqueous. Okay, so we're going to write them out. Magnesium is a 2+ charge, sulfate, 2- charge. When we combine them together, we get MgSO4 aqueous, right? Sodium has a +1 charge. Phosphate, PO4 3-. When we combine them together, we get Na3PO4, also aqueous. Okay. Okay. We want to recombine these. This is a double displacement reaction where we have a metal and a non-metal mixing with another metal and a non-metal. So remember we talked about partner swapping. So we have A and B and C and D. They're going to recombine. We're going to have magnesium. My camera's acting weird. We're going to have magnesium with the 2+ is going to combine with phosphate, right? That leaves us with sodium combining with the sulfate. Okay, I'm going to put a little line here. So they're going to recombine. You're going to get Mg3PO4 2. We're going to look that up on a solubility table in just a minute and try to figure out whether that is going to be a solid or if it's aqueous. This is going to recombine into Na2SO4. Let's look at that one also. We'll kind of mix in a little bit of chapter 7 here. So if I go over here and share I'm going to pause and open something. Hold on. Okay, so what I opened up is chapter 7, PowerPoint. And this is one of the slides partway through. On mine, it shows slide 17. I assume you guys can kind of count through and get to slide 17. So let's look at the solubility rules. So we were looking at whether phosphate or sulfate would form a solid. So when you see something on here, let's look at sulfate. Most sulfate salts are soluble. Remember that soluble means that it will dissolve. A precipitate will not form. Okay, and so we have barium sulfate, lead sulfate, calcium sulfate. We were looking for sodium sulfate. It's not on here, so we know that a sodium sulfate is going to be aqueous. It's not going to form a precipitate. The other one we were looking at was phosphate. Most sulfides, carbonates, and phosphates are insoluble. That means that these will form a precipitate. So let's go look at our magnesium phosphate. That should have an S next to it for solid. Okay. So just looking at the solubility chart, we saw that this should be aqueous sulfate. This phosphate should be a solid. So now we can write out the entire equation, and then we're going to balance it. So we're going to include all of the states of matter. So let's put MgSO4 aqueous plus Na3PO4. What is Na3PO4? It's going to be aqueous also. Yields. These are the products that we got. Mg3PO4 solid. You guys might be saying, wait a minute, you have a phosphate here. Remember I told you at the beginning, I gave it to you that it is aqueous, okay? We're looking at what was formed. That's why that phosphate's the solid. This is plus Na2SO4, which we know is aqueous. Okay, let's balance it. Remember, I draw the line down. We're going to take an inventory on both sides of the equation, so the reactants and the products. Let's look what we have over here. We have magnesium. Let's look at our polyatomic. Can we keep it together? Sulfates here, sulfates over here. We can keep SO4 together. Makes it a lot easier. Sodium. We have PO4 on both sides. Yes, we do. So we can keep that together as a polyatomic. Let's put the same thing on the other side. Magnesium, sulfate, sodium, and phosphate. Okay, let's see how many we have on each side. On this side, we have one magnesium, we have one sulfate, we have 3 sodiums, and we have 1 phosphate. Look at the other side. We have 3 magnesiums, right? We have 1 sulfate, we have 2 sodiums, and we have 2 phosphates, okay? So I'm thinking the easiest thing to even out first is we'll do the phosphate on this side, okay? So in order to get this phosphate to be a 2, we have to put a 2 coefficient in front of the entire compound that includes the phosphate. So it's not only going to affect the phosphate, it's also going to affect the sodium. So that changes our sodium to 6 and our phosphates to 2. Okay, well, let's fix sodium. On this side now, we have 2 sodiums, but we need 6. So in order to turn that into a 6, we're going to put a 3 in front of this compound here, which is going to affect both parts of it. So now we have 6 sodiums, and how many sulfates do we have? We have 3. Okay, so all we have left to fix is magnesium and sulfate. Luckily, they're together over here, so we should be able to fix that just by putting a 3 in front of it, which will change magnesium to 3 and sulfate to 3. So now we have a balanced equation. All right, so lots of balancing practice that I put online. It's up to you guys to sort of figure out how we're putting in the solid, aqueous, liquid, gas based on what's in there. And then we got into this, what you see here. I have these listed online and I didn't post the solutions. I thought we'd go through a couple of these right now, and these are where we're gonna do it all right now. We're gonna write the names, write a molecular equation, complete ionic equation, and a net ionic equation. And then we're gonna point out what the spectator ions are. Okay? So let's look at we'll take this step at a time. Let's look what we have here. We have sodium chloride plus lead 2 nitrate, right? So let's start with NaCl, sodium chloride, plus lead 2 nitrate, which is PbNO3 2. These are going to be aqueous. Okay. It yields, and then we're going to take a look at the solubility rules to figure out whether we have solid, liquid, gas, aqueous, what we're doing here. So this is going to yield lead chloride plus sodium nitrate. Okay, so one of the rules that you're going to see across the board, all nitrates are soluble. Nitrate is always going to be AQ. Okay, but let's go back and look at the PowerPoint for that slide. Let's take a look at the solubility rule here. And we're looking for a chloride. So look at this here. Number 3, most chloride salts are soluble, most of them dissolve, not silver chloride, lead chloride, and mercury chloride. Well, we have lead chloride, which means it's not soluble, which means that one's going to form a precipitate. Okay, so we know that lead chloride is going to be solid, right? You guys can go through and balance it on your own, taking the inventory, but I'm just going to tell you right now, we need 2 sodiums to balance out the sodium on the other side, and we need 2 nitrates to balance out the nitrates, okay? So if you want to go through and take a look at it, we now have same number on each side. So the 2 balanced out the chloride and the sodium, nitrates, and so forth. So now writing a complete ionic equation, we want to pull apart everything except for the solid. If there was a liquid or a gas, we would keep those intact also. We're pulling apart into ions anything that's aqueous, okay? So let's look here. We have 2 sodium ions that are aqueous plus 2 chlorine ions that are aqueous. That 2 applies to everything in the compound. Plus we have a lead 2, remember uncriss-cross them. We have a lead 2 plus, and that is aqueous, plus a nitrate, NO3 minus. We have 2 of those, right? So there's 2 nitrates, and that's aqueous. Plus, we're going to leave lead chloride together because that's a solid. And then we're going to pull apart this into its ions. So we have 2 sodium, which is aqueous, and I ran out of room again, sorry, plus 2 nitrate, which is not aqueous. There we go, okay? So we want to figure out from the complete ionic equation what is producing the solid. So we're looking at this. So let's put down the solid, PbCO2. We want to know what on both this entire ionic, the complete ionic equation, we want to know what parts contributed to this. Sodium is not a contributor. So you know what? That's a spectator ion. Let's put that down here. Okay. What about chlorine? Yes, chlorine is included in that. So we're going to put the 2Cl minus AQ plus lead. Lead is also included in making the solid. So that one participates in the net ionic equation. Let's look at the rest of this over here. Do we have nitrate involved? No. So nitrate, not even really going to put plus, just kind of a comma, 2NO3 minus AQ was not involved in making that. okay? And then we have we don't have to list them again, they're on the other side, okay? But we know that those were not involved. So they're spectator ions. So the net ionic equation of what produced this solid was the chlorine plus the lead made lead chloride. Okay, I'm going to do one more for you guys. And I'm not even going to include the spectator ions because I don't even think you're being asked that. I was just trying to get you guys to see what was left over. But I don't think I was even asking you that. And if they do, you know what it is now. But let's look at this one here. Sodium carbonate plus iron 2 chloride. So let's write out our molecular equation. So sodium carbonate, which is aqueous, plus iron 2 chloride, which is aqueous, yields iron carbonate. And I'm going to have you guys go back and look at the solubility table, but it is a solid. If you remember what we said on the last time we just spoke, the carbonates are typically solids. Plus sodium chloride, which is going to be aqueous. So let's pull it apart. What are we looking at? We don't want to pull apart the iron carbonate, right? That's staying together. So let's pull apart the rest of it. So we have 2 sodium plus the carbonate plus the iron plus the chlorine keep forgetting those, sorry, yields the iron carbonate stays as a solid. And what else do we have over here? We have, so my favorite, sodium and chlorine. So we have the 2 sodium, AQ, plus we have 2 chlorine, AQ. I need bigger paper or write smaller or something here. So let's see what the net ionic equation is that produced that solid. So I'm going to put my solid down here. Iron carbonate, let's look. Was sodium involved? No, it's not in the answer. Was carbonate involved? Yes, it is in the product that we made, the precipitate. So we've got CO3 2- aqueous plus, was iron involved? Yes, iron carbonate. We've got the iron aqueous. Chlorine is not involved, right? So this is the net ionic equation. Carbonate plus the iron made the iron carbonate, right? So hopefully that gives you guys a little bit of a review. If you have questions, please email me. If not, I'm going to assume you guys are good to go. You have your exam tomorrow. It'll be open during your regular class time. And there are no extensions and I can't open it early, so just be ready. And good luck, okay?